Welcome to the second lecture. Today we're going to be looking at SQL. Not so much giving you information directly about SQL, but how to use SQL along with your Java programs, and then specifically how to use that within the context of Java servlets. So first thing to say about SQL is that it is a standard language across the industry. It's known as structured query language and is the language that we use for manipulating relational databases. And we can do things such as create, populate and delete tables, change data in those tables, and retrieve data from the tables. Retrieving data from tables is known as querying. So when we execute queries, what we're doing is extracting data from the relational database tables and presenting that as what's known as a result set, and that is the set of data resulting from our query. There are many relational database systems, and what we're going to learn in this lecture is going to be applicable essentially to all of them, because when we connect with Java to a database, that little bit is going to be different according to the database. But thereafter, it's all going to be the same for whatever database you're using. Now, we assume that for this lecture, that you already know SQL. If you don't, then you're going to need to go on a crash course. And there's some information here, for example, which is at my website here at the university. And you can also go to other websites and books and so on to update yourself on SQL. For a lot of the remainder of this module, what you will be doing is using your Java servlets to access databases, and we'll show you how to do that in today's lecture. It is a very easy process. There are basically two things to do. First of all, set up a connection, and then, having connected, to manipulate the data using SQL statements from within the Java code. When you write a Java program that accesses one kind of database, for example, you might write it using Oracle, then if you decide that you want to change your database for that program to a different database, such as MySQL, then you've only got to change 2 lines of code in your program. Basically that little bit of code that connects to the database. There's a different way of connecting to an Oracle from connecting to a MySQL database. All the rest of the coding remains the same. And that's one of the great things, I think, about using databases within Java. Now, when it comes to connecting to the database, we need to understand a little bit about the components that we're using. First of all, we have our database, and we have our Java class. And there are 2 routes of making the connection. If the database manufacturer has provided a set of classes, Java classes, for connecting to databases, these are known as JDBC classes, then we can use those classes directly from our program. On the other hand, if, like with Microsoft Access, if the database manufacturer has not provided JDBC classes, then what we can use instead is what is known as the JDBC ODBC bridge. ODBC is an industry standard connectivity protocol for interacting with databases. And so what we can do is, on the host computer, we can create, using the administrative tools from the control panel, an ODBC driver. That driver will allow the JDBC bridge within Java to connect to that database. Either way is really quite straightforward. The only difference is, over on this route, you've got to create an ODBC driver before you're able to connect. And of course, taking this route means that there are 2 intermediate drivers for connecting to the database, whereas over on this side there's only the one set of intermediate classes. And therefore this side is likely to be a little bit more efficient in the interaction. So the first thing we have to do when we decide on the database that we use is to work out which of those two routes we're going to follow. And if you want to, probably the best thing to do actually is just to go onto the web page for that database manufacturer to see if they provide JDBC classes, and then download them. Very often they are free, and so once you've downloaded and installed them, then you can just make use of them. So the first thing we have to do once we've got our driver route sorted out is to connect to the database. The preparation for that involves these three things. First of all, import the java.sql package. In that package we'll find all kinds of classes that we need for interacting with databases. We also need to work out the URL of the database that we're connecting to. And again, that will be different depending on the database that you're using. So for example, if you're using the JDBC ODBC bridge, then you'll need to use this kind of a string. JDBC : ODBC : and then you type the name of the driver that you created. If you're using JDBC classes, and then you'll have to consult the database manufacturer for the details of that connection string. For Oracle, for example, here at the university, then what we would use is JDBC : Oracle : fin : @ and then we put in the domain name of the host that's got the database on there, the port number that the database is connected to, and then the system ID for the database that we're using. MySQL will have a different connection string, and again you need to go to the database manufacturer to find the details of those. So those are the first two things. Import, work out your URL, and the third thing then is to load the database driver manager within your program. And that's going to require, again, two options, depending on the kind of connectivity that you're using. If it's the JDBC ODBC bridge, then this is the code that you'll use. In a try-catch block, you'll have class.forName and then this string here. That string is always the same, no matter what database you're using. If you're using the JDBC classes provided by the database manufacturer, then again you're going to have to consult the documentation to find the correct name for the class. And once you've got that, then you use a try-catch block, and this time it's driver manager.register driver, and then you create a new instance of whatever the class name is that your manufacturer says that you need to use. So again, for Oracle, it will be oracle.jdbc.driver.oracledriver. That class will be in the JDBC classes that you've downloaded from the manufacturer website. And that's it in terms of differences. From here on, what we'll be looking at in this lecture is going to be the same whatever relational database you're using, so long as it supports standard SQL. I mentioned earlier that we have to import the java.sql package. As part of that package, remember a package is just a library of classes that we can use. Within that package we have a connection class. And so to set up the connection from our program to the database, we need to do this. We declare a connection object, we're calling it con, which is initialized to null in this example. And then in a try-catch block, we attempt to get a connection. Remember the driver manager that we loaded earlier? We called driver manager.get get connection and pass three parameters. The URL, that's what we prepared earlier. We know what it is. That is the URL of the database that we're connecting to. And then the username and the password for that database. What happens is that this method, getConnection, will then attempt to connect to the nominated database using these credentials. If everything works, then what gets returned is a reference to that connection object, which is then stored in our variable con. On the other hand, if it doesn't work, then it's going to throw an exception, probably an SQL exception. And in this example, all we're doing is printing the stack trace, in other words, that very sort of long list of method calls to show exactly where the problem occurred. And that's going to be printed on the default output, which for your users is probably not going to be very helpful if you just do that. But in terms of debugging, that's quite a useful thing to do. So if everything has worked and there's been no exceptions, then the connection is established to the database and you're now ready to use it. Let's take a look at querying the database. We want to extract data from the relational database, and so we have to have a query string. That is the SQL command that we want to execute. And on the third line on this slide, you can see that we've set up a variable, which is a string. We've called it SQL str, but of course, as a standard variable, it could be called anything you wanted. The string contents is actually the SQL statement that you want. But please note, there is no semicolon at the end of the string. But we are using a semicolon, of course, to terminate the Java statement. So this is going to select every piece of data from the table called service. Now the way that this is going to work is that we're going to create a statement object. Using that statement object, we shall execute a query that will then return a result set. And so we've also got a variable that's going to hold that result set. We've also got this variable here called call count. I'll tell you in a while why we're going to use that. So we've got the connection, but now we need to set up the statement. So from that connection object, we're going to call the createStatement method, which we're storing in here. And then from that object, we're calling the executeQuery method, passing as the parameter this SQL statement. Now, we have to use executeQuery because we're performing a select statement within SQL. So every time you see select as the first word in your statement, then you know that you've got to use executeQuery. That method is going to use the driver either directly through the JDBC classes or indirectly via the JDBC ODBC bridge to connect, or to communicate rather, with the database via that connection that you've set up. And we'll send that SQL command to the database. The database management system will pick up the command, will execute that command, and then we'll return the results of that query via the drivers back to the program, and we'll store an object of type result set within RS. So that all takes place as part of executeQuery. Again, if there's a problem, it might be, for example, that you've typed in an invalid SQL command, or maybe there's some other problem, perhaps you lose the connection to the database for some reason, whatever it might be, all of that kind of problem could generate an exception. Again, probably an SQL exception, and that will be trapped by the try-catch block. And so again, instead of just printing the stack trace, you would probably want to put in some useful error handling code. So we've got the result set come back. Now we need to make use of it to extract the data from the result set for our own purposes. Again, in a try-catch block. So each of these slides that I've shown so far have given different try-catch blocks around each of the code, but it's probable that what you'll have is a single try-catch block for the entire section of code, for the connection and for the processing of the result set. Now the first line in this try block is making use of something called the metadata. Metadata is information about the data. So the result set is a set of data that has got, for example, a number of columns in the result set, and will have other information about that data that's come back from the database. If we want to know about that data, such as how many columns are there, then from the result set object, rs, we're going to call getMetadata, which gives us a reference to that metadata object, from which we then call getColumnCount. And so that will tell us how many columns there are. Just popping back up one screen, you can see that the SQL statement was select star. So that's going to extract every single column from the table, and we might not know how many there are. So that's quite useful. On the other hand, of course, if we'd said something like select column 1, comma, column 2, comma, column 3 from service, then of course we know that there are 3 columns in the result set, and so we wouldn't have to query the metadata. But in this example, because we don't know how many columns there are, we're consulting the metadata to find out how many columns are in there, which we're storing here. So that down here a little bit later, we'll be able to use it as part of that loop. Well, let's come back to this while statement. rs.next is a very useful method, and it does potentially 2 things. The first thing it does is to attempt to load a row of data from the result set. If there is a row of data, then it will return true. If after the attempt to load there is no data, then this method returns false. So putting it inside a while loop's condition like this, we know that if it has returned true, that there is another row of data to process, and therefore we can enter the loop and process that row. Now, because we don't know how many columns there are, in this example all we're doing is just iterating through the data for that row, and for each column we're going to print out the information. So we've got the for loop that starts with the loop counter with a value of 1, and will go up to and include the value of column count. rs.getString will return a string containing the value, the data, held in column I. So this is one way of extracting data. rs.getString will always get that data and return it as a string. We're using here the value of I as the index of the column. The first column in the data set has an index of 1, the second column an index of 2, and so on. And so because we don't know what the column names are, we are using the index. On the other hand, if we do know what the column names are in the result set, then instead of using getString I, we could use getString, and then instead of I, we'd put a double quote, the name of the column, double quote. And so we're then extracting the data by column name instead of by index. And in this very simple example, we're just getting that string and immediately printing it out to the default output stream. And we're doing that for each of the columns in the row, and then we come back up to the top of the loop, call rs.next again, and if there's a second row, that row will be loaded and rs.next returns true. And so we then go into the loop and process the second row, and the third, and the fourth, and so on. Eventually, rs.next will attempt to load a row, and there won't be any more rows to process from the result set, and so it returns false, and we exit the loop. Now, I don't know if you've heard of the country code, but in the UK we have what's called the country code. And that is, if you're out in the country, walking through the fields, the golden rule really is leave things as you find them. So if you open a gate, then you close it after you've gone through it. If the gate was already open, you leave it open. Now, similar kind of concept here. If you've opened a result set, then you should close it. If you've opened a statement, you should close it. And therefore, having finished processing the result set, we close the result set, rs.close, and then we finish with the statement, so we close that statement as well. If there's nothing else for you to do with that connection, then perhaps you should close the connection too. It's probably a good idea to do that, because with some of the database management systems, if you leave the connection open and then your program finishes, it might be that that connection stays open. And so over the course of time, you run the program, close the program, run the program, close the program, and more of these connections are left open. And that will cause concurrent connections, and the more of those you get, the likelihood is that the performance of your database will degrade until eventually it will either crash or just be so slow as to be not at all professional. So it's a good idea to keep that connection open only for as long as you need to interact with the database, and then close it. Some databases will support quite large numbers of concurrent connections. Others support only small numbers of concurrent connections. So you have to consult the documentation really for that database to see what you can do. And of course you can also build in concepts like connection pools, so that you have a small set of connection pools open. A small section, I'll try that again. You've got a small number of connections to the database open in a pool that all the objects in your application are using. So they grab a connection. The connection is permanently open. They grab the connection, use it, give the connection back into the pool, and so on. Now, getString returns the data in the column as a string, whatever kind of value that is. So even if it is, let's say, a person's age, or it might be a count of how many children they have, or whatever it might be, if it's an integer, calling getString will still return it as a string. Now, if you know that the column contains data that is of a certain type, such as integer, then instead of calling getString, you could call getInt instead. So rs.getInt, and then either the column index as the parameter or the column name. If you want to insert data, then again you need to have an SQL string properly formatted with all the correct values and so on. Again, no semicolon at the end of the string, but we do have a semicolon to terminate the Java statement. In this example, we've just used hard-coded values, but of course, in the same way as you can use with system.out.println the catenation operator to take a string and add into it the value of a variable, and then add on to the end of that another string and then another variable value and so on. You can do similar things here. So let's say you've got a variable called ID that has got a value. Then you would put a double quote here, plus, then the variable name, ID, plus, then a double quote, followed by the rest of that string, comma, space, single quote, and so on. And that way, whatever value the variable ID holds, you've now inserted it into your string. You've constructed the SQL statement string using variable data. And that's a very powerful concept that you can use through your programs. Now this is an insert statement. Therefore, it is not a query. Queries only begin with select. Therefore, using insert means that we're going to execute an update on the database. We're not going to execute a query. And therefore, execute update does something a bit different. It does not return a result set, it returns an integer telling us how many rows were affected by the update. And so I've got a variable here that will be used to store the value that's returned, so we know how many rows were updated. Again, a try-catch block. We're setting up the connection, the statement using the connection object in just the same way as we did before. But this time, from the statement, we're calling execute update. So I just want to stress, we only use execute query for an SQL command that starts with the word select. Every other SQL command that we would use, we're going to use execute update. And we're passing as the parameter that SQL string that's been set up. That's going to send the command to the database via the JDBC class or the JDBC ODBC bridge. The database management system will interpret the insert statement in this example, will execute it, and then return an integer to say how many rows were affected by the insert. Typically it would be 1. And we're going to store that value in row count. And in this example, we're just going to output that to report how many rows were affected. But of course, we could test that. It might be, for example, that if 0 comes back for some reason, that we'll report this anomaly to the user. If we're doing some other kind of update, such as an update statement, then we might want to report that there were 4 rows updated or no rows updated or whatever. So we can test the value of row count and do whatever we want accordingly. Again, we've opened the statement, so we should close it. There's no result sets used here, so there's no need to put rs.close. Now what we're going to do now is to take a look at using these statements in the context of a Java servlet. What we've just seen, connecting to the database, was illustrated as part of just a standalone Java application, just any old Java class. But it'll work just as well in the servlet. We've also seen how to connect to the database. We've seen how to query the database and how to insert. The method of insertion will work exactly the same way for deleting, using a delete statement, an update statement, creating tables, dropping tables, whatever you want. That's all done using execute update. So, here we have NetBeans. Here is the project that you can download from Blackboard. And when you unzip it and then use NetBeans to open it, this is what you'll see. Sometimes you might find that you'll get a message to say that there are some unresolved references. Typically what you would do is to right-click on the project name, and just above properties you'll have resolve referencing problems. So you can click on that and resolve the problems. In this project, there are 2 main areas that we're going to be interested in: web pages and the servlets in the source packages. In addition to that, because we're using the connections classes, the JDBC classes for the database here, we need to take the manufacturer classes, the JDBC classes, and put them into the library for this project. So what you would typically do is right-click on libraries, and then, assuming it's come to you as a jar file, or indeed a zip file, the same would work, you click on Add Jar/folder, and that will bring up an Explorer window that you can use to navigate to the jar file or the zip file containing the package of JDBC classes that you've downloaded from the manufacturer's website. That will then list it here. So what I've already done here is use the Oracle JDBC classes and pointed this project to the jar file that contains them. So you might need to do that for your examples and exercises. Now, before we look at the servlets, I'm just going to talk a little bit about what we've got here. Here is an index.jsp. It could just as well, in this example, have been an index.html file, because all we've got here is just some standard HTML. And we've got the form. We're using a post method, so it's going to set up an HTTP post request. That's the URL of the servlet that we want to activate. And we're asking the user for the username and password. We're using a text input box and a password input box. And we're naming them uname and pword respectively. Remember, those names will become the parameter names when the request is submitted to the web server. And then we've got a submit button as well. What happens when the user clicks that submit button is that, as we saw last week, the web browser will submit an HTTP post request to the web server. The web server will pass that request on to the servlet container, and the servlet container will then determine which servlet class to activate. And the way that it does that is by looking in web.xml. So if we open web.xml, we can see that there is a URL pattern here that matches the URL that we used in the form. That URL is then found and matched against the servlet name, which is an internal name within the XML file. So having determined for this mapping that there is a servlet name, we can then look for, in the servlet tags, a servlet name that matches, which it does, and then that gives us the actual servlet class that will be executed. So what we're doing then is separating the way that the user refers to the servlet by its URL from the actual internal class name. And that can be useful for a couple of reasons. One of which is when the user downloads this JSP or HTML file, they could look at the source code for that and could work out that there's a servlet. Look, it's called Access Database. Well, actually, that's not the name of the class, and so it prevents a bit of hacking going on when users are so inclined. Okay, so that's how the servlet is identified, and the container, the servlet container, will then activate the nominated servlet. In this case, Access Database Example servlet, which we have got in the source packages in the servlets package. There it is. So if I open this up now, we can take a look at it. There's a whole load of import statements. We're doing some input and output because we're writing back to the web browser. So we're importing from java.io. We're also interacting with a database, and so therefore we're importing from java.sql. We've also got some references to classes in the JavaX servlet and JavaX servlet.http packages. So this is a standard servlet in as much as we've got our class that extends HTTP servlet. And then, if I come down here, down at the bottom here, we've got the doGet method and the doPost method. So it will support GET requests and POST requests. In both cases, all they're going to do is call the process request method, which is this one here. So let's work our way through process request. The request object gives us information about what was requested, including the parameters that came from the HTML form. And the response object, which comes as a parameter, gives us information about the response so that we can set up a connection back to the web browser and write the HTML that we're generating and sending back to be displayed for the user. So here on line 42, we're calling from that request object the getParameter method, passing in here the name of the parameter, which, of course, is the name of that text box. So the spelling here and the spelling there have got to be precisely the same. We're doing the same with p-word as well. So by the time line 43 is finished executing, we've got two variables containing data that was supplied by the user on the HTML form. We're going to write information back to the web browser, so we're setting up here on line 46 the writer, the print writer that goes back to the web browser. We're going to interact with a database. Therefore, we're going to use a connection object and a statement object, both of which are initialized to null at the moment. Don't worry about those warnings. I know they're warnings because just over here, that little line is in orange. So if it was an error that would prevent compilation, that would be red. But this is only a warning, and I'm going to ignore it. Here we have, for our university campus-based students, the URL for the student Oracle database. And you should have an account for that if you're campus-based. If you're not campus-based, then you're not going to use that at all, and you'll need to use the Glassfish database that has shipped with NetBeans. Campus-based students can do that as well, and perhaps we'll look at that sometime to see how to do it. The SQL string is a variable that we'll use because we're going to use it several times. The first thing we're going to do then is just to start writing back header information for the HTML that goes to the web browser. And then we can start interacting with the database. So you can see I've got all those SQL type statements, all the database interaction is inside a single try-catch block. So that starts in line 65 and finishes on line 87. So setting up the connection, creating statements, all the updates and queries and so on, all of that is done in the one try-catch block in this example. Because we're using an Oracle database, then we're going to set up the driver manager in this way. Then from that driver manager we can get the connection using the URL that we've hard-coded because we know exactly which URL to use. And then we're going to provide what the user gave us as username and password. Therefore, we're not hard-coding the username and password into the program, which is probably a good thing. Then we're calling this method queryDept, passing the connection and the output stream back to the web browser as the parameters. So if we scroll up now to queryDept, we can see that the parameters are the connection object and the print writer. It's probably a good idea at this stage anyway to throw exception. What that means is that this method is explicitly stating if any exceptions occur, I'm not dealing with them. So it's the responsibility of the method that calls queryDept to deal with them. Later on in the module, we'll consider how we can handle exceptions a bit better. Because this is performing a query, we need the result set, so we set up the result set object and the SQL string, set up the actual content of the string, select star from dept, use the connection that came as a parameter to create the statement, and then use the statement to execute the query that's held inside the variable there, select star from dept. That gives us a result set. We're outputting the result set table. We're just simply echoing the result set table out to the web browser. So because it's a web browser, we're using HTML, so I'm going to set up an HTML table. So we output table to the web browser, and then for each row that we get, we're setting up a tr tag, and then for each column, a td tag. Within that tag, we're passing the data, or setting up the data to be whatever is held in the column dept no, and we're getting it as a string, whatever type of data it really is. So there we've got an example of referencing the column within the result set row by its name rather than by its index. And then after that piece of data, of course, we'll need the end td tag, and then we do the same for the second column and then the third column. At the end of the third column, we have the end table row, and once we've iterated for as many rows as there are in the result set, we're then outputting the end table tag. That's the processing done. So we're going to close the result set, close the statement, and that's the end of executing queryDept. So control then returns to line 69. That's now finished, so move on to line 71. And this time we're going to create a statement for performing this insert. And then execute the update, which will give us how many rows have been affected. And we're simply, in this example, just echoing how many rows were affected. And then, to show that the insert has actually happened, we're calling queryDept again, that will output the same result set, except that it should now have an extra an extra row in the table. And then, to show you how to do a deletion, we're setting up a statement for that delete statement, executing update, showing how many rows were affected, and then just to verify that the deletion really happened, call queryDept again, so that we get to see the table after the deletion. And then when all of that is done, we've got a finally block on the try so that we can output the end body and end HTML tags. And that's how you use a database, a relational database, from within any Java program, and in this last example, how to do it specifically from within a servlet. All very straightforward. Perhaps the trickiest bit is working out what your SQL statement should be. And once you've got that, you just write the code in the way that we've shown you. And that's the end of the lecture for today.